Hello class, this is a video tutorial on further differential equations part 1. In this video we'll be looking at implicit differentiation, or as I like to think of it, differentiation as an operation. Just as we use integration as an operation that can be applied to both sides of an equation, a similar understanding can be applied with differentiation, in particular for differentiating relations. There are two ways implicit differentiation can be applied, and it's worth understanding both, as one method is more suitable than the other depending on the problem we are facing. So this idea here is that we can, using implicit differentiation, we can learn to find the derivative of relations. So if you take a look at these, you'll see that some of them are really wacky. Like take a look at this one, sine x cos y equals half. This is, it seems as if it's not even a function anymore. Okay, which is indeed the case because this is a circle, which is a relation because it fails the vertical line test. So you can pause at any time that you like. In this video, we'll be doing the first two examples with both ways of doing this. Okay, so let's get straight to it. The first method is we isolate the x's and the y's on each side of the equation. And now we differentiate this as if it were x squared. So since the derivative of x squared is 2x, well, the derivative of y squared is 2y. But because we differentiated this with respect to x, we put, with respect to y, we write dy. And we do the exact same thing on the right hand side. We differentiate this with respect to x. So the derivative of x plus 4 is just 1 dx, because we differentiated the right hand side against x. Now, moving things around, dividing by dx, we get dy on dx. Dividing by 2y, we get 1 on 2y. And this is the derivative of this relation. Okay, now let's demonstrate the other way in which we can differentiate it. The other way is we think of y as a function of x. So this can be written as f of x squared equals x plus 4. Now, if we were to differentiate this, okay, we would treat it as if it were the chain rule. So we differentiate the outside first, so 2 to the front. The inside stays the same. We put, instead of 2, it'll become 1. So we apply the chain rule to this, but like the chain rule, we need to multiply by the derivative of the inside. The derivative of f of x is f prime of x. And the derivative of the right hand side is just 1. Okay, but now remember, f of x we can treat as if it were y, so 2y times, the derivative of f of x is f prime of x. Well, we can notate that as y prime equals 1. Dividing by 2y, we get y prime equals 1 on 2y, which we know that y prime is dy on dx equals 1 on 2y. Okay, so now you don't have to write it like this to begin with. If you can already imagine this straight away like this, you can proceed straight away like that. Okay, so let's do the second example. You can pause and try and apply it yourself using both ways. Okay, so with the first way, we have to isolate x's and y's on the left and the right hand side. for this, just for the fun of it, I'm going to move y to the right-hand side. You could try it with x, and we must get the exact same answer, but let's go with this one. So it'll be x squared equals 9 minus y squared. The left-hand side, I differentiate with respect to x, so it's 2x dx. And on the right-hand side, I get negative 2y dy. Dividing both sides by dx, my right-hand side becomes dy on dx. And dividing by negative 2y, I get 2x over negative 2y, which finalizes to dy and dx is negative x over y. This is the derivative of this circle. Now, applying the second method, I'll demonstrate to you without using the f of x notation. So it'll become x squared plus y squared equals 9. So we're differentiating everything with respect to x. So the derivative of x squared is 2x. The derivative of this, remember, looks kind of like this. We differentiate the outside. It's 2y times the derivative of the inside, which is y prime. The derivative of 9 is 0. Okay, so moving things around, I get 2y times y prime can be written as 2y y prime equals negative 2x. Dividing by 2y, we get y prime equals negative 2x over 2y, which we can substitute now. dy and dx equals negative x on y. Alright, so that concludes how we can differentiate, implicit differentiation. I hope you can see that we can actually now differentiate non-functions and find the derivative of relations, not just functions now. So hope to see you in the next video where we tackle the last 4 examples, and hope to see you then, and best of luck.